All right, taking a look at quiz number 3 from last year. All right, again, just as a point of reference, right? These aren't practice quizzes. These are, of course, quizzes from last year's class, so these are not made. We always emphasize different things different times, but there's always good information on here to learn. So take a look at number 2, C. It's asking you, what is the relationship between these two isomers? So one of the first easiest things to do is to number your carbons. All right, number your carbons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, I'm trying to match these two carbons together. Match the carbons on one molecule to the carbons of the other one. Notice since we're comparing two things, right? There's only so many things they could be. They can't be meso, right? Things aren't meso to each other. A compound is meso, so that doesn't work here. We look, are there any asymmetric centers? Are there any sp3 hybridized carbons with 4 things bonded to them? No. So our other option is either they're identical or they're cis-trans isomers. So if they're cis-trans, you want to look at the alkene. So if they're identical, they both would be E, or they both would be Z. So the question here then, we need to decide first, is that alkene E or Z? All right, so what is this alkene right here? Between 2 and 3, what is that? So carbon versus hydrogen, which is not drawn in, but it's there, right? This carbon wins. Carbon versus hydrogen, this carbon wins. So they're on opposite sides, that would be a E alkene. Go to the other side. Again, there's H's, but we just don't draw, we draw them in later. Carbon wins, carbon wins. So this is a Z alkene. So these two to each other are cis-trans isomers. Right? Everything's the same except the alkene in one is E and the alkene in the other is Z. So looking on that same problem, but looking at, we'll do F. Well, D, E, and F kind of all the same idea. Again, you'd be best served, so if we look at F, the best thing you can do is probably number the carbons, right? Because we're kind of rotating things a little bit on you here. So on F, you have this, L, OH, and you also have Cl, Vr, OH. And they're asking you again, what are these to each other? So you can probably eliminate a couple things. We know they're not cis-trans isomers because there's no pi bonds. There's no alkenes. But then we got to figure out what they are in relationship to each other. So, all right, some people, I mean, you could have said, I guess I can see how you could have said cis-trans, but really that's usually a term we use for pi bonds with most compounds. Right, once you start having these stereocenters, we usually refer to them as either being enantiomers, diastereomers, or identical. So I get you could have wrote cis-trans for one of these if you really wanted to, but it wouldn't be the best answer probably, right? The cis-trans are really meant for the pi bonds. But I would number the carbons. So let's number bromine 1, 2, 3, 4, 5, 6. So bromine is 1, 2, 3, 4, 5, 6. So you look at this and say, okay, so bromines, looks like that has switched, right? That's flipped. So if this was R, now it's S. I don't know which one is which, but it's flipped. It's inverted. It's stereochemistry. 2 is also flipped. The chlorine is also flipped. And 4 is also flipped. So they're all 3 flipped. So when they're all opposite of what they were before, what do we call that? Then they're enantiomers. Right? Enantiomers, remember, everything is flipped. Right? They're enantiomers to each other. So that's a pair of enantiomers. If one thing was different, if just one was different, then they'd be diastereomers, and they have different physical properties too. Good. So sticking with quiz 3 again from last year, from 2014. It says, how many possible stereoisomers are there for the following compound? Now this is a little bit of a trick. This is a 7-membered ring. And normally what you do is 2 to the n, where n is equal to the number of asymmetric centers. Right? So 2 to the n, where n is the number of asymmetric centers. And here you would say, right, I have 1, 2 asymmetric centers. So you'd expect how many stereoisomers? 4. So you'd expect 4. You don't get 4. You actually get 3. Because this compound has a meso-isomer. Right? A meso-isomer. One of its stereoisomers, actually 2 of them are actually the same. Because this molecule has an internal mirror plane, you could divide it down the middle. All right, it has a mirror within it. Think about these two stereoisomers are like our hands. If you cut it in half, the molecule has a mirror plane. So what does that isomer look like? What do these isomers look like? So if you draw them all out, you'd see it too. If you try to draw out all 4, you'd see it. So let's try to draw out all 4. So I'll both see those that way. Both this way. So, right, these are the 4 isomers you normally expect, right? If this center right here was R, it could be RS, right? You could go down the line and see all the possibilities. The problem is, this one right here and this one are actually the same compound. If you just took this and flipped it on its head, you'd get this. So these 2 isomers both have mirror planes, right? So they count as, right? This counts as one isomer, because they're the same. If you flip them over, they're exactly the same. So they're both, this compound's meso and this compound's meso. Well, this is the same, these are the same thing. So that only counts as one isomer. Now these 2, I can't flip this one and get this one. These 2 are actually different. Right? These 2 are actually different. Right? These 2 are enantiomers to each other. Right? If I labeled these all as A, B, C, and D, right? C and D are what to each other? They are enantiomers. Everything's opposite. What about C and B? What are they to each other? They're diastereomers. What about A and B? What are they to each other? They're identical, right? Good. Right? Meso means one compound can be meso. You don't use meso to compare things, right? A and B are identical. A is meso and B is also meso. They're the same thing, right? So they're both identical. So in this case, you only have 3 stereoisomers, not the normal 4 that you'd expect. Taking a look at number 4 on the quiz. Number 3. So let's look at the first 2. So we split our alkene in half, right? We're going to compare these 2 things on this side, right? So in this case, we have carbon to carbon, so that'd be tied, right? Now this carbon, what it has is bonded to a carbon and then 2 H's, right? Whereas this carbon down here is bonded to 3 H's. So high card always wins. So in that case, That'd be this one. So that gets priority, right? Carbon beats hydrogen. All that matters is the first card we play. Now we go over to the other side. Carbon and carbon, right? Tied. What does this carbon have? It has a chlorine, a carbon, and an H. This carbon has a carbon, a hydrogen, and a hydrogen. So again, which wins? The chlorine wins. So this side gets priority. So this would be a Z isomer. For the next one, the ring, a little different. Okay. Again, we'll split the alkene down the middle. Just like before, carbon and carbon tied. This one's bonded to another carbon. This one's bonded to H's. I'm not going to go through that again. So that's wins. Next one's a little tougher. So carbon and carbon, so tied, right? This carbon is bonded to what? It's bonded to an oxygen, a carbon, and an H, right? Whereas this carbon is bonded to an oxygen, right? 2 bonds, pi and a sigma, and a hydrogen. So this one would be oxygen, oxygen, H. So first thing, oxygen to oxygen, that's still a tie, right? Carbon to oxygen, now this wins. All right, so in this case it'd be E. Always go one carbon at a time and then just like playing cards. All right, taking a look at a nomenclature problem. Bromine out there. See a trace. Okay, so with this sort of problem, you want to, first thing you always want to do is identify the parent chain. Right, so you got to find the longest continuous chain with the functional group. And in this case, the functional group that takes priority is actually the alkene, right? The alkene is the important thing, not the bromine. The alkene is important. So we want to have the longest chain with the alkene. So the longest chain with the alkene would be 1, 2, 3, 4, 5. So I'll just circle the longest chain. And I could have gone down here, right? Because these two methyls are right? They're actually not quite the same, but wouldn't matter, right? Because this alkene can't rotate. Is this alkene cis or trans? E or Z? No, so we don't have to worry about that for the naming, right? Because 2 methyls, we can't differentiate those two, so that makes it easier. Now we got to decide which way we want to name it. We want to name it from right to left or left to right. So we want to make it so we have the lowest number possible for the functional group. So let's name it from right to left. So then it'd be 1, 2, 3, 4, 5. So it's pentene, right? But we got to say where the double bond is at. Where does the pi bond start? So we need to put a 2 in front, right? To say the pi bond starts at carbon 2 and goes to 3. So we have to put a 2 there, 2 pentene. And then we need to say what else is off it. So there's a methyl. So there's a 2-methyl piece somewhere, and a looks like 5-bromo. So B comes before M. So it would be 5-bromo, 2-methyl, pentene. Right. And it would be even more, it could get even more tricky, right? If we had decided this was E or Z, then we'd have to put a 2E or Z out front. But we don't in this case, because methyl and methyl are the same. All right, let's do some Rns problems. So this is very similar to number 3 from the quiz. So you're getting something like this, something else out there, whatever. So let's start with this. Not worry about, there's some extra stuff out here. Couple places you're going to slip up. First thing you need to do is you need to put your wedges and hatches in correctly. So if the wedges and hatches aren't, or if the H is missing, right, for all of these, the H is not drawn in. So you need to correctly draw the H in. That seems silly, but right, if this is hatched, the H will have to be what? wedged, right? But now we have to draw the H wedged such that it's on the same side as the hatched, right? What I saw some people doing is they want to put the H over here. No, no. You have to put the H on the same side as the hatched. Now don't confuse this. Is this a Fisher projection? No. Fisher projections, remember, will always look like this. If it doesn't look like this, right, this is that bow tie thing, right, where these two things are coming out at you and this is going away, right? Remember Fisher projections? And these would be going away. But it'll have to be set up like this T. If it's not set up like this T, it's not a Fisher projection. When it's like this, you want the wedged and the hashed on the same side. So don't confuse Fisher projections with these normal structures. So you have to draw in the wedge or hatch correctly. So in this case, we have to draw the H in on the same side as the wedge, right? You could draw the H over here too, it doesn't matter. Gotta draw the H in on the same side as the hatch. That's the first thing people screw up. You gotta draw them in on the same side. Okay. The next thing they'll mess up is the rankings. You'll mess up the rankings. If you screw up the rankings, you're gonna screw up the problem, right? So you have to rank them correctly. Right? First of all, you gotta rank them correctly. So let's just take a look. Let's highlight this one. Let's do carbon. We'll call this carbon A for right now. So what's the highest priority in carbon A? So that's 1. What's the lowest? H, so that's 4. Or we could say, if you want to start doing it this way, we could say red and green. So what is white? What's the second highest priority? Is it to the right or to the left? To the right, I think is, right? Because this carbon is bonded to a carbon and a carbon, whereas this just bonded to another carbon. Right? So this would be white, and then this would be blue. So you need your red going away from you, your green coming at you, kind of in the down spot. Blue to your left, white to your right. Whatever one that is either Rs. I will throw down the other problem people will do, is they forget, right, clockwise and counterclockwise. So clockwise is what? Rs. Clockwise is R. CC is S. And remember, of course, it's red, white, and blue. Right? Remember the order. Red, white, and blue. You hold the green ball. You turn the thing towards you. Right? And you say red, white, and blue. Clockwise is R. Counterclockwise is S. So which one is it? So we agreed that this one actually is, A is R, the R isomer. Couple things, again, clockwise R, counterclockwise S, red, white, and blue is the order. If you have two things like this, right, the green is coming at you, red is going away, you need to have the blue and the white kind of above them, up top, right? Make sure they're situated so the other two balls are above this part, not below it, right? They have to kind of get it mapped on there. So let's try this one up here. Let's call this one B. So the lowest priority is what? H, so that is, we call that green. The highest priority is which one? The carbonyl, the ketone, so that would be red. This next one would be which? Are we going here or here? Which one is white? The bottom one, right? The bottom one is indeed white, and then this would be blue. Now sometimes it helps to just kind of isolate ourselves, so let's see where we can get that one to be. So for B, I have it as R as well, right? Again, green coming at you, blue going away, and kind of to the bottom, to the left, and then down. Red is to the left, white is down in the plane. Whatever isomer maps onto that, that's the right one. In this case, it's R. So, practice, with a couple of slip-ups people will make. Where they draw the wedges and hatches, they have to be next to each other, right? Unless it's a Fisher projection with something different, it'll be drawn like this. You need to make sure you rank correctly, right? Rank correctly. And then clockwise, of course, is R, counterclockwise is S, and you say red, white, and blue. You grab the green ball, turn it towards you, and say red, white, and blue. They're the keys.